Right, for the review, this is going to be the video for topic 7 and topic 8. So topic 7 was dilations and similar figures. So 15 here says, what is the scale factor of the dilation shown? So there's two ways to do this. The first way is to find the center of dilation, which we're not going to be able to find here because it's going to be off the charts. So we're going to use the second way is we're going to look at how long the sides of this figure are, and we're going to compare it to the corresponding side on the other one. So you're going to start by picking 2 points. I'm going to pick A and D. Okay, and then I'm going to pick a direction. So I'm going to pick up. So this distance here is 2. Okay, if I want to do the left and the right as well, I can also do that. And then this distance here is 1 unit. Okay, if I go over to the other one and do A and D again, right, it's the time it's going to be 4 up. And this time it's going to be 1, 2 over. Okay, so my scale factor, right, is going to be 4 over 2 or 2 over 4, which is going to give me 2 or 1/2. It doesn't specify, but when it doesn't specify, we're going from the regular one to the one with the primes. So A, B, C, D to A prime, B prime, C prime, D prime, which means we're getting smaller. So our scale factor should be 1/2. Okay, it's half as big, right? Our new one, the A prime, B prime, C prime, D prime, is half as big as the original. All the points would also be half as far away from the center of dilation. The center of dilation would be somewhere up here. Number 16, we have a dilation by a scale factor of 1.5. Since it doesn't specify what the center of dilation is, we're going to assume it's 0, 0, the origin. And since the center of dilation is 0, 0, you can simply multiply all of these coordinates by the scale factor, 1.5. So x prime is going to become 4.5, comma 0. Y prime is going to become 6, comma 3. And then z prime is going to become 9, comma negative 3. So you're just simply multiplying the x and y coordinates of each point by the scale factor. All right, number 17. We have 3 ways to show that triangles are similar. Angle-angle similarity. Right, so we have angle-angle similarity. We have side-angle-side similarity. And we have side-side-side similarity. Angle-angle similarity was, we had to show that we had 2 pairs of corresponding angles that were congruent between the 2 triangles, then they would be similar. Side-angle-side was if 2 pairs of sides were proportional, and the angle between those sets of sides was congruent, then it would be similar. And then side-side-side is if all the sides are proportional. So for number 1, we have 1 pair of angles congruent, 1 pair of sides congruent, and that's it. So we don't have enough information. So there's not enough information. So something like NEI, not enough information. Oops. All right, for the next one, we have, remember the biggest side, if these are going to be similar, the biggest side is going to have to match up with the biggest side of the other one, and the smallest with the smallest. So the biggest side on this one's 30, the biggest side on this one's 15. So if these are similar, right, 30 would match up with 15, and then 26 with 13. And then 26 with 13. Okay, and if all the ratios of the corresponding sides are the same, then the sides are going to be proportional. So all of these ratios are going to equal 2. Okay, so all the sides here on triangle MNL are twice as big as the sides on triangle QOP. So we can say that, yes, these figures are similar by side, side, side. All right, see here, you have 1 pair of angles congruent, and again, 1 pair of sides. And there's no other information we can add. We can't add anything else. So this one's going to be not enough information. All right, and then this one over here, again, biggest with biggest. So 28 over 14. And then 10 over 5. Those ratios are both 2. So we have 2 pair of sides that are proportional. And then we do have the angles between them. They're both right angles, so they're both 90 degrees. So angle V is congruent to angle X, which means we have 2 pair of sides proportional, and the angles between those sets of sides is congruent in the 2 triangles. So yes, these triangles are similar by side angle side. Okay. Number 18. If the width of the pond shown is x feet, what is the value of x? So on this one, it shows that AB is parallel to DC, which means angle D and angle B are congruent because they are alternate interior. So that tells us that the x is going to match up with 60. So we set up a proportion, x over 60 equals, and then 80 is going to match up with 48. Cross multiply, so we're going to cross multiply here and solve. So that's going to be 48x equals 480. I'm sorry, 4,800, right? Should be another 0 there. Right, and then divide by 48, and you get 100. So 4,800. So x equals 100 feet. Actually, x equals 100 because it has feet after. Okay. Number 19. When Esteban looks at the puddle, he sees a reflection on top of the cactus. How tall is the cactus? So the angle of that you're looking down is going to be the same as the reflection off the other side. So we have one pair of angles there. The cactus is at a right angle and the man is standing at a right angle. So now we have 2 pairs of angles congruent. So these triangles are similar by angle similarity. Now, since they're similar, we know the sides are proportional, so we can set up a proportion. So 1.5 is going to match up with x, right? 1.5 matches with x, the height with the height, equals, and then 2.5 over 10. Okay. This is the denominator is 4 times bigger, so you could just multiply this by 4 if you wanted. But if we want to do it out, we could cross multiply. So that's going to be 2.5x equals 15. And then you divide by 2.5. And that's going to be 6 meters, right? So we're solving for this. So this will be 6 meters. The cactus is 6 meters tall. All right, topic 8. Right triangles and trig. So we have 3 different things we could do. Right, we can do the Pythagorean theorem, a squared plus b squared equals c squared. And then we have the sine, cosine, tangent. And then we have the inverse sine, inverse cosine, and inverse tangent. All right, the first one here, we have 2 sides of a right triangle, and we're looking for the third. So whenever you have 2 sides already and you're looking for the third, you can use the Pythagorean theorem. So a squared plus b squared equals c squared. Right, so the hypotenuse is always the c. So our hypotenuse here is going to be the x because it's across from the right angle. And then the 2 legs of our triangle are going to be the a and the b. So we have 12 squared plus 9 squared equals c squared. Or x squared. We can plug in x or substitute in x for c. 12 squared is 144. 9 squared is 81 equals x. Add those together. That should be 225. Right, 144 plus 81 gives us 225 x squared. So 225. And then to get rid of the square, we have to take the square root of both sides, and that's going to give us 15. So x here is going to be equal to 15. All right, the next one, we have one side and we're one angle and we're looking for another side. So that's going to be regular trig. We have a side and one of the acute angles. So we're going to use trig. So we got to label our triangle. The hypotenuse is the blank side. Okay, circle the angle. 5 is next to, so that's adjacent. X is across, so that's opposite. And if we remember our mnemonic, SOHCAHTOA, right, opposite and adjacent here is going to be tangent. So we're going to do the tangent of, we input the angle, tangent of 60 equals, opposite is x, adjacent is 5. All right, we can multiply 5 on both sides. So we get 5 times the tangent of 60 equals x, right, because those cancel. And then I can put that into my calculator. 5 tangent 60. And I get 8.7. So x is approximately 8.7. All right, next two, C and D here. So on this one, the two sides are congruent. So it's isosceles, so you can put the x here as well. Okay, and then we can do the Pythagorean theorem, x squared plus x squared equals 6 squared. Or if you wanted to, since this is a isosceles triangle, these two angles have to be 45 degrees. So you could do a special right triangle, 45, 45, 90. You could do trig you could use this 45 and do cosine, or this 45 and do sine. But I'm just going to do Pythagorean theorem. So x squared plus x squared, that's 2x squared. And then 6 squared is 36. If I divide both sides by 2, I get x squared equals 18. I can take the square root of both sides, so I get x equals the square root of 18. If I want to simplify this, I'm going to divide this into a perfect square. So x equals 9 times 2. And then the square root of 9 is 3. So this is going to be equal to 3 times the square root of 2. Right, so each one of those are 3 square root of 2. And again, you could have used special right triangles and divided 6 by the square root of 2, and it would have gotten the same thing. All right, D here, again, two sides, and we're looking for a third, so we're going to use Pythagorean theorem. So 4 squared plus x squared equals 10 squared. And again, on this side, the 10 is the hypotenuse. And then these are your two legs. So this has to be your C. And then the 4 and the x have to be the A and the B. 4 squared plus x squared equals C squared. Leg squared plus leg squared equals hypotenuse squared. So that is 16 plus x squared equals 100. Minus 16 from both sides. Subtract 16 from both sides, you get x squared equals 84. Take the square root of both sides. You get x equals the square root of 84. If we want to simplify this, we need to find a perfect square that goes into 84. So that would be 4, I think, right? 4 times 21. So we can split this into 4 times 21. And the square root of 4 is 2. So that's going to be 2 square root of 21. E. We're going to have E here. Do a different color for E. All right, we have one side and we're looking for a second side and we have an angle, so we have to use trig. Label the hypotenuse, circle the angle, opposite is x, adjacent is 5. We're going to use our mnemonic, SOHCAHTOA. So, TOA. All right, we have opposite and adjacent. So again, this one's going to be tangent. So I'm going to do the tangent of 48 equals opposite, which is x, over adjacent, which is 5. I'm going to multiply 5 on both sides to get it out of the denominator. That's going to leave me 5 tangent 48 equals x. And then I can put that in my calculator. 5 tangent 48. And that gives me 5.6, approximately 5.6. And that makes sense because the 48 degrees is slightly larger than the other angle, which would be 42. And so this side should be a little bit bigger than this side. All right, the next one, we're solving for an angle, so we have to use inverse. When you solve for an angle, we got to use inverse trig. So I'm going to label my hypotenuse. I'm going to circle my angle, and then 11 is opposite. It's across from the x. So if I have opposite and hypotenuse, that's going to be O and H, which is sine. And we're using inverse sine because we're solving for an angle. So inverse sine, we input the ratio, which is 11 over 23. Into our calculator, and that's going to be equal to x. So if I do that in mine, the inverse sine of 11 divided by 23, I get 28.6 degrees. So this angle here would be approximately 28.6 degrees. G here. So we're solving for a side, and we only have one other side, so we need to use regular trig. So I'm going to label the hypotenuse, which is 12. And I'm going to circle the angle. X is across, so that's opposite. If it's opposite, we're going to use sine. So the sine of 37 equals opposite, which is x, over the hypotenuse, which is 12. We can then multiply both sides by 12 times 12 times 12. And that cancels. And we're left with 12 sine 37 equals x. I'm going to put that in my calculator. Sine 37. And I get 7.2, approximately 7.2. Smaller than my hypotenuse, so it's probably pretty good. All right, next one, we're solving for an angle. So I'm going to label my hypotenuse, circle my angle. 6.5 is next to the x, so that's going to be adjacent. Opposite and adjacent is going to be cosine. So I'm going to do inverse cosine because I'm solving for an angle of 6.5 over 10. So inverse cosine 6.5 divided by 10 gives me 49.5 degrees. 49.5 degrees for x. Last one here. Two office buildings are 100 feet apart. So this distance here is 100 As shown, from the edge of the roof to the shorter building, the angle of elevation to the top of the taller building is 28 degrees. And the angle of depression to the bottom is 42 degrees. How tall is each building? Round to the nearest foot. So what we need to do is we need to first look at this top triangle and find the height. And then you need to look at the bottom triangle and find the height of the bottom one. So let's first start with the blue one on the top. So if I circle the angle, I know the adjacent is 100, and we're solving for the height, which is x. So we're going to use tangent because that's opposite. So I'm going to have tangent 28 equals x over 100. And now I can multiply both sides by 100 to solve for x. That cancels. Now I have 100 times tangent 28 equals x. I put that in my calculator. It says round to the nearest foot. So let's do that. So 100 tangent 28. And I get 53, approximately 53 feet. Right. Now let's do the red one. So we circle this. Again, the 100 is adjacent. And we're solving for the height, which is going to be y. So again, we're going to do tangent. So it's pretty much going to be the same thing, except instead of 28, it's going to be 42. So tangent 42 equals y over 100. We're going to multiply both sides by 100. And we get 100 times tangent 42 equals y here. All right, and then put that in my calculator, 100 tangent 42. And I get 90, approximately 90 feet. All right, so that red height here, the height of the small building, is going to be equal to 90 feet. Right, the height of this triangle is the same as the height of the building. And then the height of the tall building is going to be equal to 90 plus 53, which is going to equal 143 feet. Okay, so your tall building there, right, is this entire thing, oops, wrong color. Right, this entire thing. So you're going to add x, which is 53, plus y, which is 90. And then the small building is just simply that height, which is 90. All right, and that's it for the topic 7 and 8 review for the final.